You know, I had to do a photo shoot first.
I know.
I'll Photoshop you guys. It's okay.
All right.
No double chins allowed.
That's why I have a beard.
That's what I do too. I can't shave it.
Chris, are we clear to start? Good. Hello, hackers. Welcome to our talk titled Command, Control, and Memes. Today we're going to share with you how we prepare to control remotely compromised assets during offensive security operations, how we use command and control infrastructure for that, and how we can make the whole process of deploying and provisioning these resources painless, quick, and efficient by using infrastructure as code. Tony will show us how he goes about developing a C2 framework, talking about some of the internal components of it. For today's presentation, we'll cover a brief introduction, some who am I, what problems do command and control frameworks address, how these problems came to be historically, what are the components in a deployment, as well as a deep dive in how do we go about automating the deployment of these resources and provisioning using configuration management tools. Tony will finally close out with what are the components of developing, if you consider bringing in your own C2 framework, how you go about automating that.
Hello, everyone. I'm Josh Huff. I'm a senior red team operator at Humana. I have about 15 years experience in cybersecurity, and makes me feel kind of old saying that out loud. But about 6 of those have been in offensive. Before that, I was blue team. My 2 favorite topics in offensive security are OSINT and infrastructure. I like to find new ways to get traffic in and out without defenders catching us, and then who doesn't like some good detective work in OSINT. I'm a husband of 10 years, been with my wife for 18 years total. We have 2 kids, a 2 and a 5-year-old, and they keep me more than busy, but when I do have a little bit of free time, I have a life that not a lot of even my friends and family know about, but I'm a musician on Twitch. So since I have love of infrastructure, and that's what this talk's about, and a love of OSINT, I wanted to do an OSINT challenge for you guys. If you could find out who I am on Twitch and either pop into a stream or find me on my Discord and say, hey, I saw you at CactusCon or something like that, I'm going to offer a 3-month subscription to the Cyber Mentor. I'm not affiliated with him at all, but I know he puts out good training, and I wanted to kind of give back to the community, so I'm going to try to give back to him and to you guys. So that's enough about me. Move it over to Robert.
All right, folks, so my name is Robert Pimentel. I am lead of offensive security at Humana's Red Team. I have about over 11 years of experience with information security, network security. I have some certifications, and I have an absolute love for automation. I swore to myself I was never going to deploy and configure Kali Linux or Debian or Linux for that matter manually ever again before an engagement. Too many nights wasted doing that. But more importantly, I am energized, completely energized and motivated to share, help knowledge, because I have made some substantial progress in my career due to others being generous with their time and knowledge as well to me. I love pugs. We have a family of soon-to-be 4 pugs, Brazilian steakhouses, eating my fill with that. And I probably didn't drink way too much coffee, as Josh Huff can tell you during morning stand-ups at work.
What's up? I'm Tony Fontana, senior penetration tester at Dark Wolf Solutions. Primarily drone hacker, stepping into red team and malware development. Unlike these 2 with their automation, I just reinstall Windows or Linux 300 times and takes hours of my time, but you know, get it done. Have a couple of certs. I've only been doing this for about 2 years, but have a true passion for malware development. That's like the coolest thing that I can think to do. Love red team and obviously love C2 infrastructure, and just developing my own seemed like a good idea. And then that was like 6 months ago. I'm still working on it, so it's just something that will eat your time, and it's super fun. It's a great way to learn how to do it and figure out what they're doing. But I'll turn it over to Josh, and he'll get us going.
Thanks, Tony. So Robert's going to go over kind of the cool automation aspects of everything, but before we do that, I wanted to kind of touch on some of the fundamentals and what it is, so we're all kind of level set what goes into C2 infrastructure. So in the early days, it was just somebody with a terminal, command prompt, or bash or something that was remotely gaining access to another machine. Then in 2003, with Metasploit, which most of us has probably either used or at least heard of. It's kind of a turning point and kind of enabled some other things. C2s have evolved since then with like Cobalt Strike, Brute Retil, just to name a couple, but there's dozens of them out there. At its core, C2 kind of manages the problem of how are we going to communicate with our target machines. So it sends commands to them and then receives data back from what they sent. So it allows us to execute strategic actions on a target, establish covert communication channels through protocols such as HTTPS, SMB, DNS, and avoid detection from the blue teams. So what are these strategic actions I'm talking about? Well, imagine you exploited an Apache Linux server. You receive a callback, and now you can download files, you can establish persistence, you can enumerate the network, enumerate the machine, manipulate traffic flow, maybe camouflage yourself by moving to another process. Or on the other hand, maybe you gain access to a user's workstation. So with that, you can do some of those same things, but you might want to focus on like keylogging or capturing screenshots or the clipboard or something like that to kind of gather intel on what the user's actually doing, who he's communicating with, what applications he's using, maybe even grab some credentials. So the C2 framework itself, like I've mentioned with Cobalt Strike and Brute Retil, those aren't all that goes into this. For the infrastructure, there's different components like the C2 server. Now this is where the C2 framework is. It's kind of the main backbone of the infrastructure. You have to have that to be able to have infrastructure. Whereas the redirector is optional, but it's very much recommended, and we'll kind of get into that in a little bit. And it's just kind of a middleman that manages the traffic between the C2 server excuse me, and the target. We have our implants, which are your payloads, which is the actual malware that you execute on your target machine, and that's what gets you your callbacks to your C2 server. And then we have the payload server, which is just a means to deliver that payload, whether it be within the C2 itself, or if we have like a S3 bucket or something like that, you could house it in. So whenever we set up our communications, we want to be able to execute commands and everything, but we also want to establish some persistence. We want to be able, if we get compromised in some way and they cut off our connection, we want to be able to get back in there. So we have what's called short haul and long haul communications channels. The short haul is where most of your traffic's going to be. It's where you're telling it what to do and it's giving you data back. And because of this, it's a little bit more high risk of detection. So you may get blocked there. So we also establish a long haul connection, which may call back every few days, every few weeks, every few months, depending on your operation. And that's just to reestablish short haul connections should you become compromised. You want to blend in more with the traffic there and just not use it so nobody really sees that it's happening. So we'll dive a little bit deeper into each component. The C2 servers I like to think of as like the red team's quarterback. So we're relying on that to get out on the field and be the heart of the plays. We, the operators, are more like the coaches or coordinators. We're coming up with the plays. It's our strategy we want to implement, but we need the C2 to actually go out there and execute it. So as with quarterbacks, even your most avid fans may not know some of them. There might be some smaller schools or maybe your second and third string quarterbacks that people don't know. But C2s are kind of the same way, and these are like our Peyton Mannings and our Brett Favres and Tom Brady's of C2 frameworks here. These are some of the bigger ones that people use. They're both commercial and open source here. Notice that Windows kind of dominates the market because it actually dominates the market of what people use. Most companies primarily use Windows or even exclusively use Windows. But some of these do allow for Linux and Mac OS, so that's something you definitely need to consider depending on the target environment that you're going for. These frameworks come in different shapes and sizes. Some of them are nice GUIs like Cobalt Strike here. You can see you've got a box pops up to create a listener. It's got drop downs in there. It's got form fields that you just fill out. It kind of tells you what you need to create that listener. And the listener is what you use to create a payload, and then that's also what listens for the payload to come in for those communications of what it wants you to do. You also have a nice chat box there that the operators can talk in, and it tells you when you got your initial callbacks. And then at the top there, it shows each one of your callbacks, and you can just right-click there and interact and run whatever commands you need to. Also, it's not part of the GUI, but I included a screenshot there of the malleable profile, and that's where you can make some different changes, like to the network protocols and stuff to kind of help you blend in better. On the other hand, you also have some frameworks like Sliver here, which is command line interface. Has its advantages and disadvantages. It's not as pretty to look at. It doesn't have these nice boxes telling you what to fill in. You have to know what you need to fill in. But once you kind of have a hang for it and you've used it, a lot of professionals prefer this. It's a little more efficient and just a streamlined way of communicating with the C2. It's really a matter of preference or what that C2's capabilities are and what you need. So back to football analogies. I hope there's some football fans here. If not, I'm sorry. Maybe if you're not, you'll start watching football because you see how much it relates to your job now. 2023 was the year of all the Taylor Swift fans, and 2024 is going to be the cybersecurity professionals. You're welcome, NFL. So if you don't know what the Wildcat offense is, basically it's when the ball snapped to a player that's not the quarterback, like a running back or a wide receiver or something like that. And we can do that with C2 applications also. You can use legitimate business applications like Exchange, OneDrive, Dropbox, GitHub, stuff like that. To make it look like that, sorry, to make it look like that is just legitimate traffic, but it's actually set up as a C2. A lot of these frameworks that utilize this stuff, they're kind of limited, so they're great for like those long haul channels that we were talking about, because they'll allow you to like regain access and stuff like that, but they're not going to have all the stuff that Cobalt Strike or Mythic or something like that's got in it. All right, so you set up your C2 server and fished a user, got a payload back, good to go, right? Let's pump the brakes for a second because we haven't talked about redirectors, so we might have got ahead of ourselves. Even Michael Scott here is kind of cringing that we didn't put a redirector in here. So why is that? Why is it? All right, so let's say you set up the direct connection like we said, no redirector. Incident responder Gary, he sees there's a multi-stage incident involving command and control come in. And he's pretty good at his job, so he recognizes this isn't a good thing he needs to investigate. So he looks into the IP, sees it's not related to any kind of business services or anything like that, and he recognizes SATA ranges, and basically at the end of his investigation, he ends up blocking you. Well, now your C2 server is directly compromised, he knows what it is, and you pretty much have to start over. So first of all, if there's any incident responders here named Gary, thanks for letting me use you without permission. Robert here will be paying out royalties if you want to send him an invoice after the talk. He's the guy to talk to. He'll square you away. But second, we let Gary win. And it's okay to let your blue team win. Like, it's a good thing if they win. But don't let them win that easy. We need to do something to kind of make it a little more difficult on them. So let's look at what we could have done to avoid this. If we just would have put in a redirector, it would have been okay. Maybe even multiple redirectors. You can set up more than one that all call back to the same C2 server. But it hides what your C2 server's actual identity is. You can have multiple IPs and domains that's pointing to that. And one more football analogy, I'm done, I promise. Think of it like the offensive line. So you put that in front of the offensive line is there to protect your quarterback. It's there to redirect defensive players off of him. Without it, they would just go straight to him and take him out. And if you have one of your offensive line players that's injured, you could probably replace him pretty easily without much of a game changer there. But if your star quarterback gets taken out, you might lose. It's kind of the same with this. If one of our C2 redirectors gets taken out or one of the paths to the redirector gets taken out, that's fine. We can just pivot and move on. But if they actually find our C2 server, we've got to start over because we've got a problem. So with all the football analogies out of the way, Robert's not going to have any of those. They're done, and I'm going to pass it over to him.
All right, so now we have a good overview. Thank you, Josh. That was a great job going over the C2 components and some idea of why we need redirection. We have about 4 methods we're going to discuss today on how to achieve C2 traffic redirection, being the first one at layer 4 or transport layer for protocols like TCP and UDP. In this case, our star player today is going to be Socket. If you have spent any time working with capture the flags or penetration testing training, you might have run across Netcat. I like to think of Socket as a Netcat that has a lot of life experience, and it has learned that adaptability is survival in a world where the only constant is change. And I bet that you never thought we could hack words into poetry, but here we are doing it at CactusCon. Thank you, folks. Now, on a more serious note, what you're seeing on the screen is a Socket UDP redirector to have a DNS redirector for DNS traffic, right? In this case, we would be using DNS traffic to control a compromised asset, and we're using Socket to forward the UDP datagrams from the redirector server to the C2 server. Because UDP and TCP have differences in how they're implemented and their capabilities, so a redirector needs to handle the traffic differently. Because UDP does not have control messages that allow, in contrast to TCP, to say, hey, the connection is over, move on, we need to implement a timeout. This timeout will essentially indicate that after a certain period of time, for the command that you're seeing on the screen, this is 5 seconds, if you don't receive new traffic, cut the connection and move on. We also need to fork, which means to clone the socket process in memory for every UDP datagram that is received. On the other hand, if we had TCP, we wouldn't have to implement this timeout because TCP does have a control message like fin or reset packets that say, hey, I'm done communicating, move on. But we also need to fork if we're using TCP because we still need to handle simultaneous connections. So we use some of the same capabilities on the socket side, but the reasons why we might use these capabilities are different on the protocol side. Now, if we didn't apply any of these timeouts in the UDP example, just to give you some depth there, what would happen is that your process table would eventually get filled, and as you know, or you might not know, there's a kernel side limitation on the amount of processes that you can have open at the same time. That is a finite number. Now, if we move on to our second method of redirecting C2 traffic, we can talk about network address translation. This one provides us with a slight edge on performance because Socket, being a process, lives in user land, so it has some other considerations there. In the case of IP tables, which would be our tool of choice for implementing the network address translation operations, we can use a program that is already implemented at the kernel level. Now, there's two operations that are relevant for forwarding C2 traffic if we're using network address translation. The first one would be rewriting the destination IP address in the IP header so that the original packets that were sent from the compromised asset destined to the redirector are now sent to the C2 server. The second operation would be rewriting the source IP address of the IP header so that the packets that are sent to the C2 server, the C2 server responds to the C2 redirector instead of the C2 implant, which is where the traffic is originally coming from. If you had, just as a thought exercise, the C2 server send traffic back to the C2 implant, this is traffic that could be picked up by defenders on the target network. And this is certainly a non-ideal scenario because it could leak where the C2 server it actually is hosted, where it's addressed, giving the defenders some information that they can go off to either engineer detections or policy level blocking. Our third method to redirect C2 traffic would be using a reverse proxy. So being the first method at layer 4, the transport layer, the second method, that is TCP UDP forwarding, the second method being on the network layer by just rewriting where and how the IP traffic is handled, right? Like source and destination IP addresses via network address translation. The third method is at the application layer. So essentially we're using a reverse proxy to handle all this logic, and it allows us, in terms of advantages, provide more granular filtering. So essentially what we can do with reverse proxying is match traffic that has certain characteristics, and if the traffic meets these characteristics, send the traffic to the C2 server. If it doesn't, send the traffic somewhere that's less conspicuous, somewhere less suspicious, right? So let's say that we're compromising a customer, in the case of consulting, if you do work like Tony does, or if you work in an internal red team like Josh and I, you'd want to forward the traffic to some page that perhaps is commonly used by the users. Therefore, when the defenders, and there's ways to continue investigating this is just like a first line of defense. When the defenders start investigating where the traffic is originally being sent to from the compromised asset, they can see that, oh, this is just another healthcare site, or in the case of the company that we work for, or Tony, if he's hacking a aerospace engineering company, well, then send the traffic to some other, non-suspicious, benign site. Now, in the case of reverse proxying, you have several applications you can do this with. There's similar to the other two, right? But this one has a way bigger variety in the sense that essentially any application that you can use for a web server, you can probably configure for reverse proxying, right? I'm putting some examples on on the slide, like Apache Nginx. There's other tools like Caddy. If you follow Marcelo Salvati's work, ByteBleeder, he has some posts on using it with Caddy. The fourth method is one of domain fronting, which I'm sure that if you've spent any time trying to be stealthy in a network or getting around egress traffic filtering, you might have come across this. Domain fronting allows us to abuse a cloud service provider infrastructure to seem like the traffic is being sent to the same place where developers are building their first-party services on. And it's very interesting. Josh and I have had great success using this method very recently, and you will see that if you start researching this method, you'll see all sorts of headlines talking about how cloud service providers have allegedly fixed this, but we just got a egress callback from Azure Front Door last week, so it still works. Now, the interesting part here is that for defenders to be able to fend off someone using domain fronting, they would have to have full SSL interception and being able to decrypt the traffic, which it's a tall order. Now, some controls that this will allow you to bypass are things like Zscaler. Back in the day, I think it was called Blue Coat. I'm sure Broadcom bought that company, and it might be called something else, but essentially forward proxies, right? Well, this is good for the section on how to forward the C2 traffic. Let's talk a little bit about infrastructure automation, which is the crux. We wanted to give you a good overview of what it is that we're even trying to automate and what these things are used for. So essentially, there's two big high-level steps here. We need to first deploy the resources that we're going to use, and after we need to configure them according to the operational needs that we have. So in this case, we're using Terraform for the example. However, please know that you're not limited to this solution. Terraform is just the example that we chose, but essentially any cloud service provider has their own automation and templating infrastructure as code solutions, right? Like in the case of AWS, you have CloudFormation. In the case of Azure, you have Biceps. So there's many options there. Now, what you're seeing on the screen is the main.tf, like the main Terraform file, and this is, I want you to think about it as the entry point of the Terraform project. Essentially, this defines that the API that we're going to use, so where we're going to be creating the resources is AWS, right? You're seeing that on line 2, the required providers, line 3, AWS, and line 5, the version of the API, right? On line 8 through the end, you're seeing the backend that stores where the Terraform state file is going to be. The state file, I want you to think about it as a list or an inventory of all the resources that are being created and maintained with the infrastructure as code. And essentially, the reason we're using a storage service to keep this this state file is because this provides our deployment with robustness in the sense that if we lost this state file, then we would have to recreate it, and it's not an ideal scenario, let's just say it that way for the sake of the presentation. Now, what we have on the screen is an instances file. I want you to notice on line 46 how what we're defining is a C2 team server resource, which is just an AWS VM. And we'll show also in the next slide one for the C2 redirector, right? So, but what I want you to focus on for the moment being is that from lines 47 through 54, there's different parameters that define characteristics or attributes of the resources that are being created, right? So on line 47, we have AMI, which is just Amazon's flavor of operating system. It stands for Amazon Machine Image, and it allows you to browse a catalog of already pre-configured assets that have the operating system, so you don't have to spend that time setting up Kali, going through keyboard layout, mirrors, updating the packages, etc. You just literally reference that ID, and you'll have a Kali machine created, if Kali is what you want to use, but it doesn't have to be. It has to be Debian, Windows, Mac OS. I think they have just about any operating system there. If we move on, we have things like instance type, which, as you will see in the next slide, is a common thing if you're doing virtual machines, right? You want to define the size of the machine, how many CPUs it has, RAM, etc. Even the network speed you can define with this, right? Now, I'll move on to the next slide to show that in this case also, we're deploying redirectors, but some of the same parameters apply, right? Like we have the AMI, we have the instance type. We also have key name, which is the RSA key that we're going to use to obtain a console session, SSH, or however else you're going to connect to the resources. And you have things like count. So let's say that for this project, we needed to have I don't know, 11 redirectors, right? You can define that with the count and be able to have those 11 redirectors at the end with just literally the same code. Now, here's something I want to put in your mind now, but we'll look at it in a future slide, is the fact that every value that you're seeing, lines 149 through line 156, has bar dot, and it has the name of a variable after, right? So what this allows us to do is bring in some level of modularity to the code so that we can reuse the same project and just change a variables file that we'll take a look in a moment what it looks like. Essentially what this allows you to do is not to have to rewrite your whole project every time that that you have some new operation going on. So let's say that Huff pings me over, our instant messages, hey, we have this operation we need to prepare for. We're going to need X amount of redirectors. They need to have this network speed. They need to have this operating system. We just literally go and change it on our variables file, and we'll see what that looks like in a moment. The other thing that is very interesting to automatically deploy is domain fronting distributions. We were talking about how domain fronting allows us to bypass egress network controls like forward proxies. So that's something that you can also automate. You can essentially create a given number of domain fronting distributions. Those are CDNs. Domain fronting is really the technique. The resource is legitimately used for content distribution networks. It's something that developers very commonly used. It was originally they used in mobile applications and whatnot, and that's a different context story for a different day. But what matters here is that we can deploy a given number of domain fronting distributions, and we can point them to a domain that is where our actual C2 infrastructure is stored, right? Not stored, but where it lives. Now, the interesting thing here is that depending on how complex we want the design, this is just a very simple example, right? If we're supporting multiple team servers, multiple redirectors with the same infrastructure, we can point and change the different origin ports, right? So if I wanted to support several HTTP and HTTPS listeners, I can have a myriad of arbitrary ports set up there, right? And you can see in Hacker Hermano's YouTube channel, we're creating this type of content and doing even deeper dives. For today, for the sake of the example, I'm just putting a very simple example, right? And we're giving these talks on Fox Hunt's server. We have Josh and I do these talks also in internal events at our employer, but you can find more of that content that delves into some nuances and deeper considerations for more advanced architectures. All right, so we talked about the domain fronting distributions, what they look like. Now we're continuing on the same file. If you notice, last line is 25. Here we continue on 26. This allows us to define some other granular characteristics of the CDN distribution. Like, let's say, an important one. Let's say that Tony and Rudy over there are doing an engagement that has a target or a customer that is only in the United States. There's really no reason why they should allow traffic from Russia. So what this allows you to do is implement a geographic restriction that says that the traffic will only be allowed ingressing the domain fronting distribution if it's coming from the US. And like many things, this is just a layer of security. This is not a end-all be-all, because as you know, any actor can really deploy assets whatever they want in the world, especially in the world of cloud and automation, like we're seeing here. But it's just something to keep in mind. Something that is very important is that as offensive security professionals or red teamers, you're not patient zero of a breach, right? That would be a bad day for the company. After the resources are created, something you'll want to do is have an output to the standard output, or depending if you're deploying with a pipeline, which we'll talk about in a moment, to the console, some values. Like, you have the C2 servers, the C2 redirectors. You want to have the public IP so that you can actually SSH and connect to the resources and start your operations, right? Start using the infrastructure that you created. So as you can see with the outputs file, we can do that. We reference the value in the resource type, which is in line 2, value AWS instance, and this is the name of the instance that I want you to output the public IP. The star that you're seeing in between is because, as you remember, we had set a count of multiple resources, so I want you to output every single IP of every single resource that I created. And you'll see what that looks like in a moment. Similar thing for the domain fronting distribution. We're showing the domain name, that's line 14 over there, and the ID of the distribution, that's line 11. Okay, so as you'll see in the next slide, which is this one, you get a list of IPs for all your redirectors, a list for IPs for all your team servers, and a list of URLs and IDs for your domain fronting distributions. I used some obfuscation here, as you can see. there's some data missing, but you'll get the idea. The reason for that is I'm not going to share actual live IPs, even though those resources don't exist, and don't try to find them. This is an example of what it looks like when things are created on a CI/CD pipeline. The example that I'm using is Azure DevOps, but essentially any pipeline solution will do the same. I just wanted to give you some exposure because these are very abstract things, so being able to look at them graphically does set the concepts better, in my opinion. We talked about operational security and how we can bake that into some of the granular characteristics of the domain fronting distribution. We can do the same as well with the traffic that we're allowing ingress and egressing. So I want you to keep in mind that what you're seeing is a security group definition. And in this security group, we're allowing, this is for a C2 redirector, so we're allowing HTTP, HTTPS traffic, DNS traffic, but we are blocking any other traffic like RDP, SSH, because there's no need for that. This is an example of the variables.tf file that I was talking about earlier. The variable for use1 AMI Cali is referring to a variable that's defined in the variables file, but it's just called by the variable name on the instances.tf file. Similar here with the instance type or the size that defines the number of CPUs and RAM like I was mentioning earlier. And here it's talking about the security group, that's line 50, the security group that is assigned to this resource that was created, as well as the count on line 51. I want 8 of those C2 team servers. This specifically was for an engagement where Huff and I were comparing several C2 frameworks that are commercially and open source available, so we had to deploy essentially every single one of them and do a bunch of tests with each one and see how they perform so that we could make an informed decision as to which frameworks we're going to use for future operations. All right, so now we've finished configuring all of our resources. As I was mentioning earlier, we have a list of all the APs, everything is created, life is good. Let's configure these resources. For that, the solution here is Ansible. There's many other solutions. You don't need to use Ansible. That was just what fit our needs, so we went with that. Plus, there's a lot of resources already available with Ansible that allowed us to speed up and cut down on development time. But essentially, you can do this with Vagrant, Packer, I don't know, Jenkins, if you feel like getting on RCE on your on your build resources, etc. Anyway, so lines 8 through 16, what you're seeing referenced there is Ansible roles. Ansible roles provide another layer of modularity. That's an important consideration. There's many with infrastructure as code, but essentially modularity is a big one, right? Because that gives you the possibility of creating or writing reusable code. If we spent X amount of cycles on this iteration just building our automation, we don't need to spend those cycles again in the future, right? We can just reuse it and reuse it and reuse it, get quicker to our operations, get quicker to hacking, provide bigger business value, get to the findings, which is the reason why we have a job as offensive security professionals. Now, these roles that are called from line 9 through 16 are 5 C2 framework roles. On line 11, it's a VPN solution, and lines 9 and 10, just some couple quality of life solutions, like things like a shell theme with syntax highlighting, etc., and as well as a terminal multiplexer that allows you to, in the same SSH connection, just open multiple panels and be able to do multiple operations at the same time. Ansible is a YAML language which makes it very visually easy to understand and easy to follow, as well as to continue extending the code. Now, something else that comes to mind is that when you're deploying multiple resources, you get a list of IPs, like the one that I was mentioning earlier, right? That I showed in the slides a couple times. To provision the Ansible resources, you need to call an Ansible command. So something you can bake into your Terraform code is to output a shell script that calls Ansible and the playbooks and the roles that you're interested in installing after the resources are created and provides the IPs for each. This is what it looks like. Lines 3, 9 show an example of the command with the actual IPs of the resources that were created. These are ephemeral resources that don't exist anymore, so I invite you to connect to the IP if you're so inclined. But essentially, after I run this script, it'll start applying the different changes that provision the configuration, installing the C2 frameworks, installing the VPN, etc. Now, moving on, we have a definition for a Ansible role installing the C2 frameworks. This one downloads Cobalt Strike, provides a valid license, unpack the archive, updates it, etc. Same thing with Brute Ratel. This one has Interesting tidbit, I noticed that the author of Brutatel likes to update the website on the weekend. You need to go to his website to download the latest version. So what I added was a check that the website was up. In contrast to a more mature, bigger operation like the one of the providers of Cobalt Strike, that the site is pretty much always up, I realized that my code was failing for some reason, and when I noticed the website was just down. So I added that. It does the same thing, downloads the software, extracts the archive into the file system, updates it, activates everything, and you're ready to go. Now finally, for the automation portion, and we'll hand it over to Tony in a minute, if you want to bring another level of maturity, you want to use CI/CD pipelines. Josh Huff and I work in a very small red team. We have all different specializations. We have a malware developer. Huff and I are focused on infrastructure. And you have to think about the output of your projects as a service. So essentially, our malware developer does not need to be concerned with the nitty-gritty of building and automating infrastructure because he has better shellcodey things to do, right? So what we do is, hey, with a CI/CD pipeline, you can just press this button. You're going to get a number of C2 infrastructure, and you can just get going on your development of malware and evasion and all those things. So that's where CI/CD pipelines come in. Left-hand side, you have a pipeline that just creates resources. Right-hand side, you have a pipeline that destroys all the resources. And this is what it all looks like end-to-end, right? And for this specific example, everything completes in like 15 minutes, and boom, you're ready for an operation. So, Tony, you want to take it away?
Thank you. Please calm down. All right, so what am I going to talk about? So everything that Robert and Josh were talking about is super cool. I like to go a step further when I learn something new. I'm like, oh, I'll just program it and see what it does. So I'm going to go over what makes a C2 a C2. Programming, it's fun, I promise. Just it's only fun when it's evil. The programming languages that you can use, the components that go into a C2. We're going to break it down, and then any questions that you guys have, seriously, don't make it weird. Ask questions, because then I'll just stand up here and talk to myself. All right, so who's this for? This is literally for anybody that wants to get into malware development, C2 development, blue team, red team, anybody that wants to understand what's going on under the hood of these C2s. Who's it not for? Don't go out and try to make a C2 and then rob a bank, because you're going to get caught, and then I'm going to laugh at you. And don't hack your ex's Facebook. It's super weird. Just let them go. Like, seriously. All right, let's build a C2. We're not actually going to build a C2 because it takes months. But let's hit some of the major components. Why would you want to do it in the first place? Because there's all these different great open source C2s. There's Havoc, Sliver, Mythic, just to name a few. I would say that you do it because, one, when you're on a red team, all those things have very, very, very well signatured IOCs, so you're gonna get caught. Like if you just try to, turn up Havoc and then go, you're gonna get caught. So if you make your own, you're gonna have very unique IOCs. You're gonna be able to understand exactly what it's doing, so you can make very small changes to it. And then it's just a lot of fun. Like when you make a C2 and it runs, and then you can bypass CrowdStrike with it, feels pretty good. Not gonna lie. But yeah, so let's hit all the major components. We're gonna go over front end, back end. We're gonna go over some verses, malware agent, beacon, implant, bacon, daemon, whatever you want to call it. All right, so the front end. That's everything that the user's gonna see. There's so many programming languages that you can use for it. You could use Django, which is Python, React, TypeScript. You can use C++ if you hate yourself. JavaScript. There's so many that you can use that it's insane. And then kind of what Josh was talking about with a GUI or a CLI. Like there's so many people out there that love CLI because it's just fast, but a GUI is nice because if you're like me and you have crippling ADHD, then you kind of have to have these things in your face all the time so that you can say, oh yeah, that was doing something, I need to go back to that. So they each have their use, and it's how much time you want to devote. Obviously CLI is going to be a faster build because you don't have to spend 6 hours with ChatGPT trying to figure out how TypeScript works. Let's see. And then you have the back end, which the back end is a little bit easier. I mean, it's the server. So you can actually put multiple servers into a server. You could have like a team server, a main server, ops server. The cool thing about this is you can really build it any way you want to suit your needs. So there's tons of programming languages for this. But when you're looking at what programming language to use, and this goes for front end too, like, does it have a lot of API? Does it have a lot of like rich API libraries that you can use that just reuse code so you don't have to reinvent the wheel? Golang is great for servers because it's basically just like designed. It feels like it was designed to make C2 backends. Thanks, Google. That's awesome. Python is another really good one. There's a lot that are written in C#, C++, HTML. No, you can't write one in HTML. That's nuts. But yeah, there's potentially hundreds of things connecting to this. So what's going to make it easiest for you? Like, you don't have to like go nuts and try to make Cobalt strike right out the gate. You can even just take like Havoc or another open source and rework it. But yeah, I would start with Golang. Agents. These have like a bazillion names, like malware, beacon, agent, payload, virus, daemon. I forget what Sliver calls theirs. I think they're just implants. But programming language consideration for these is actually a lot more. When you're writing malware, you want to make sure that the language you're using is like, there's a programming language out there called NIM, which is fantastic. However, you can't even make a regular NIM program without Defender freaking out about it because it's so heavily used in malware that even just regular programs get flagged as malware. So like the size of the compiled binary, is it compiled or is it interpreted? Like, C versus Python. If Python's not installed on your target, then it won't work unless you make it any executable. And then Windows API support, like, that's super important because as you saw on their slide earlier, Windows is king when it comes to C2 frameworks. Like every single C2 out there supports Windows. They don't necessarily all support Mac or Linux, but they will all support Windows. So when you're looking at programming languages, like I said, it's not all inclusive. Like you can even make your own. Like I know a guy, he's 17, he's like half my age, and he's already written his own programming language. It's awesome. C's my favorite because it's fast, it's compiled, and it's pretty much owned by Windows. So everything that you could ever need for API support is in C. NIM is my second favorite. NIM's like a safer C. It's kind of like Rust, but a little different. Rust is great too, up and coming. It's like the replacement for C. And then assembly. The assembly language is probably one of the most important things for making your agents because if you can alter the assembly, then you can pretty much evade anything because you're changing it on a machine level. C#, it's a huge one. People love their C#. Golang's another one. It makes massively bloated binaries though. So which actually can be a good thing, but PowerShell, yeah, you can make an entire C2 in PowerShell. You can write your own language, like I said, which is, yeah, don't do that. That's if you're starting out, don't try to write your own programming language. Python, yeah, Python. Considerations, like, does it support the Windows API? Like, I get it. You guys hate Windows and you all use Black Arch and Vim, like that's fine. But you have to be able to utilize Windows well. Like that is where I would stay. Like is probably the most important consideration that I have when I'm looking at languages. Can you call inline assembly? Does it handle assembly well? Like can you just drop assembly files in there? It's not always possible, and that's if you go and look at any of the open source C2s. Or like any of the like Hell's Hall or Hell's Gate for syscalls, there's assembly in there. So it's definitely something that I would look at. And do you know how to use it? Like, no is the totally acceptable answer. I didn't know how to use Golang until I started doing this. And then what's your goal? Like, what do you want it to do? Is this something that you can just turn out real quick and it doesn't matter if some of the nuance doesn't matter, or is this something that your company is going to be using as like your company's personal C2? Is another consideration I would make. Then I decided I needed one slide that was very hard to read, so I chose this one. The planning side. Like, I am not a planner. Like, I wrote all these slides in like 30 minutes and then didn't do very much rehearsal. Sorry, Robert, that's my bad. But I can't stress it enough. Like, you back everything up because you're going to break it. Always do it on a VM because, like I was saying earlier, the infrastructure, like setting up your infrastructure is important because I bricked my laptop like 3 times yesterday and had to put Windows back on it. Plan everything out. So, like, I use flowcharts, like, just any kind of flowchart. You start with one and then you just branch and it'll grow and it's going to become huge. But if you tackle each one of those independent areas of the flowchart as you're going, then you'll end up with what you planned instead of like, you have this extensive malware that all it does is change your mouse button from left to right. Like, that's, yeah. Here's an example. This is one of my earlier flowcharts. If you look at the bottom, there's like that black spot down there. That's like the equivalent of a coffee stain that wasn't supposed to be there. I'm not hiding anything under it. But this is very basic. This was like right when I was starting, and it's grown to something that's massive, and it's a great living, breathing document when you're working with a team. They can go in and they can see what you're working on. They can take like their own little block, add stuff, and then so it makes working as a team really, really easy. And yeah, here's more of it, just more kind of a little closer. And then one thing that I like to do too is anytime I think, like last night at like 2 in the morning, I had an idea. And so I texted my wife in the middle of the night to remind me to do something today. But normally I go in and like put it in this flow chart and then end up, oh yeah, I was thinking about doing that. So organize yourself. That's the moral of the story. Here's an example of a GUI that I was working on. And this is written in React with TypeScript, or it's written in TypeScript using React. And it looks like a lot's going on, and it really is not that complicated. So this was probably about 5 hours of learning how to use React and TypeScript. And it's not in this picture it's not fully functional, but it didn't take much longer to actually get everything to function. But yeah, I mean, I'll invite Josh and Robert up for questions. Seriously, don't make it weird. Thanks, brother.
I love your definition of simple.
No, you're gonna make it weird.
Quick disclaimer, Huff hasn't updated his LinkedIn in like 3 years, so if you want to contact him, just contact me and I'll make sure you get to him. So, just that.
True story.
All right, we got questions. Start over there. What's up?
So I'm going to restate the question. For the front end, do you use Electron or React?
So funny story about Electron. I went to implement Electron, and then it broke my front end so bad that I had to just start over. But yes, I thought about using Electron, and it's smart to use because it's if you don't know what Electron is, it's essentially a headless browser. So it looks like a web app, or it looks like an application instead of like you're running it out of a browser. But yes, I did think of that, and it's a good idea. I broke it, so let's see. Other questions?
Aside from writing your own malware and maybe malware analysis, how much coding, programming do you need to know for more the regular team?
So the question is, aside from malware development, malware analysis, how much coding do you need to know for just general red teaming? I mean, that kind of depends on your role. I think you guys probably be better answering that one. You guys are full red teamers.
So as with any specialization. You have folks in different teams with different roles. In the case of our specific team with our employer, Huff and I are more focused on infrastructure, so setting up everything the team needs to go and actually do the operation. We have a gentleman that's fully focused on malware development and making sure that the implants and the tradecraft that we have is perhaps loosely based of things that are off the shelf that you can find online, but re-implemented and rewritten in programming languages. That's a very roundabout way to say that it depends. At the same time, it also depends on what you're trying to achieve. If what you're trying to write is malware, then I would pick the language and have the considerations that you want for that specific sort of malware, right? Like Tony made the reference of NIM for defense evasion some time ago. It wasn't as commonly seen, so that was a good choice to start writing your own tradecraft in NIM, because you wouldn't find many other things that are written in it. Therefore, detections were not up to snuff. But now that's different because folks caught up to that. Everybody and their mom started writing their malware in NIM and their loaders, etc. So I'm sure you've heard about the hello world gets picked up in NIM as if it was malicious, when it's not the case. So you need to certainly be comfortable with memory manipulation, writing shellcode to memory, calling it. Depends how deep you also want to go, because if you want to be like really evasive, then doing the same memory allocation calls that common malware has and that you would find in your typical like Maldiv Academy and things like that are going to get picked up, right? So you need to come up with new ways. And if you want to also advance tradecraft and like come up with something that hasn't been implemented yet, and you need to do your own research, then you need to be very, very comfortable with things enough as to come up with creative ways. I hope that answers your question.
Anywhere from like
Huff wants to add something to this last question too.
I was going to say, too, even if you're not a great coder or whatever you're specializing in doesn't really need coding, being able to review it and, like, the different tools that you're grabbing to use, you need to be able to at least know enough that you can look at them and make sure that they're good to go. There's nothing malicious in there that you're finding, or maybe make some slight modifications or something like that, too.
For implants, right?
So the question is, can we go into more depth about what defenders are looking for and how to evade it? That could be a talk in and of itself. So, I mean, I can catch you after and we can talk about it. But there's so many things, like anywhere from like just like if you compile your code in VS Code or Visual Studio, like that in and of itself will create a bunch of IOCs. So it just really, it depends on how far into the weeds you want to go. But yeah, I can catch up with you after and I can talk to you about it. Because yeah, it's full talk.
Let's take some questions from over here.
Yeah.
What's your go-to C2 for Mac-based environment?
So go-to for Mac-based, go-to C2 framework for a Mac-based environment. I'm going to get back to you on that question, because that is something that we have on our roadmap to start working on in our organization. I'm sure there are things out there, but nothing that comes to mind right in the heat of the moment right now, to be quite honest. Some other questions from over here? We're just at about time for the next talk, so unless you have a question we want to get answered, you can also contact us via social media. Glad to, reach out. This is what we're here for, so have a good day.